Class 9 children, we have entered in the third decade of 20s, and this is going to be my very first lecture in the year 2021, where we have entered already and we have spent a fortnight. So children, bringing a very voluminous topic today, I admit, because it was getting very difficult for me to make it in a summarized and precise way. But still I have tried my level best that the lecture not becomes too lengthy and you also understand it in a most beneficial way. So this will remain my effort. Let's see that whether I am getting successful in my effort or not. That all will depend upon how do I deliver my lecture, but I am looking forward that it will remain great. So what is valency? Always it has been asked to me by the children that ma'am kindly explain the term valency, and because it always gives us goosebumps. Children always get little much scared to know about the valency, because the term is not very, you can say, simplified. Little much complexity is there, but I am trying. Valency, children, because you already have studied about the Bohr's model of the atom. It is a very close term related to the Bohr's model of the atom. Do you remember in the Bohr's model of the atom, we distributed the electrons in a way, and that way was called electronic configuration. And in electronic configuration, the electrons were distributed in a fixed number in the different shell like K, L, M, etc. Every energy level was keeping fixed number of electron, and they were fixed, having fixed energy level. So at the last we find that every atom has a valence shell. What is valence shell? Valence shell is that shell which is the outermost shell, and I told you at that time that the outermost shell keeps the maximum energy, because the energy goes ascending from lower towards the higher energy level. So the electrons present in that outermost shell make the element either reactive, most reactive, least reactive, or non-reactive also, you can say. Yes, we have example of non-reactive elements also, which combine with lots of difficulty, or they just do not combine at all. So valency will be what? It is nothing but the combining capacity. In chemistry, what do we call valency? The combining capacity of any atom with other atoms to form compound. Chemical compounds are formed when the atoms combine with another atom, means one element combines with another element, and they become stable, because they come in the molecular form. Molecular form is the stable form, because there the atoms gain their stability. How do they gain their stability? They gain their stability by completing their octet. What is octet? I hope that you have good idea of octet now. Just telling you more. So you have idea about the filling of the electrons in the different shell by gaining the idea of the Bohr's model, and you know that electrons get filled in fixed number in the different orbits. तो जो सबसे बाहर वाला ऑर्बिट होता है, जो जिसकी एनर्जी सबसे ज्यादा हाई होती है, इसको कि हम लोग वैलेंस शेल कहते हैं. उस शेल को, जो कि आउटर मोस्ट शेल है, इज कॉल्ड वैलेंस शेल, एंड द नंबर ऑफ इलेक्ट्रॉन्स विच आर प्रेजेंट इन दैट वैलेंस शेल इज योर वैलेंस इलेक्ट्रॉन. This valence electron becomes deciding in determining valency of any element, children. Just keep it in the mind for forever. Valence electrons decide the valency, and these valence electrons actually are responsible for the chemical reactivity of the atom, because these valence electrons are having highest energy in that atom. So इन इलेक्ट्रॉन्स को थोड़ी और अगर एनर्जी बाहर से प्रोवाइड की जाए, आयोनाइजेशन एनर्जी जो कहते हैं, तो ये या तो लूज हो जाती हैं, या फिर गेन हो जाती हैं, या फिर शेयर्ड होती हैं. तो अगर लूज हो रही हैं तो लूज किस केस में होती है और गेन किस केस में होती है, शेयरिंग कहाँ होती है, ये मैं आपको आज क्लियर करने वाली हूँ इस लेक्चर में. Now I remind you about the Bohr-Bury scheme, जहाँ आपने पढ़ा था कि every atom tries to attain the octet, and once it attains the octet in its particular orbit, एक orbit ने जैसे ही octet attain कर लिया, उसके बाद मैंने आपको बताया था कि it stops filling the further electron even though it has capacity more. So that is applied here, and that will decide also the reactivity. So Bohr-Bury scheme is very much applied in deciding the valency of the electron. अगर ज़्यादा इलेक्ट्रॉन है वैलेंस शेल में, ज़्यादा इलेक्ट्रॉन है अगर, तो वहां पर गेनिंग होगी। अब ये समझने वाली बात है कि जब पहले से ही ज्यादा इलेक्ट्रॉन, तो वाई इट विल गेन? यस, suppose that if the outermost shell is keeping 5, 6 or 7 electron, then it will be just 1 electron either, or 2 electron either, or 3 electron less in finding the octet. It is just behind 1, 2 either, or 3 electron in gaining, in attaining the octet. इसके पास इतनी ही की कमी है, तो ये इस कमी को कैसे पूरा करेगा? It will gain either 1 electron, 2 electron, or 3 electron to become octet. Or if there is just 1, 2 or 3 electron in the outermost shell, this I am telling you the case of metal. अगर मेटल में क्या होता है कि जब एक जो सेकेंड इनर शेल होती है, जिसको कि हम लोग पेनल्टीमेट शेल भी कहते हैं, आउटर मोस्ट शेल के पहले वाली जो शेल होती है, उसमें इलेक्ट्रॉन कंप्लीटली फिल्ड होते हैं ऑक्टेट, और जो बचे हुए इलेक्ट्रॉन 1 या 2 या 3 होते हैं वो दैट गोज इन द आउटर मोस्ट शेल. In that outermost shell, these 3 electrons make the atom reactive because they hinder the stability, they disturb the stability of the atom. ऑक्टेट इसके पहले वाले शेल में बनी हुई है, उस ऑक्टेट को लेकर ये स्टेबल होना चाहता है, सो इट लूजेस दोज इलेक्ट्रॉन, एंड बाय लूजिंग दोज इलेक्ट्रॉन दैट ऑल्सो गेन्स ऑक्टेट एंड बिकम स्टेबल. Or if there is an atom which has completely filled outermost shell, then it will not gain, or it will not lose, or it will not share any electron, and its reactivity will become, combining capacity means, I mean to say, will become 0. And such type of elements are also available, which are also called noble gases. So the noble gases do not have any valency. They are called zero valent because their reactivity is 0, and all the other elements, be it metal, non-metal, or metalloid, tries to gain the configuration of noble gas to become stable, and this stability it is done either by gain, loss, or share of electron. Then you must be identifying this atom. It is sodium, which has 11 atomic number, and the electrons are distributed like this in K shell 2, L8, and finally M shell is your valence shell. So in the valence shell, how many electrons do you find? 2, 8 to 1, because it has 11 electrons, and this is how it is distributed from lower to higher energy. This one electron, I have represented it by red because it has very high energy, and that energy is making the atom unstable. So it will lose this electron because already it is at the higher energy, and so little much of energy we are providing from outside, then the electron will come out and it will be lost, and this is your valence electron. So this valence electron will decide its valency, यानी कि यहाँ इसकी valency 1 होगी, क्योंकि 1 electron जो है वो combining है, and that is present in the outermost shell naturally. So children, I given you one example of metal, and that is your sodium. And in the sodium, how you seen that loss of 1 electron is making its dream to fulfill octet. Sodium जो है वो stable हो जा रहा है. तो there are different ways to complete octet, and this is done by the either gain, loss, or share of electron, and this capacity will determine, this capacity of gaining, losing, and sharing of electron will determine its valency as well, because losing, gaining, or sharing is done for what? It is done to complete its octet. Now, like here I have shown you another example, and this is the example of your non-metal, a pure non-metal, fluorine. That was the example of sodium, where I shown you that how it is losing electron, and here I will tell you that how it is gaining electron. So fluorine की atomic number क्या है? It is 9, so it will have 9 protons, therefore 9 electrons also. These 9 electrons will remain distributed in 2 energy level, K and L, as your 2 and 7. तो 7 इलेक्ट्रॉन जो है इसकी वैलेंस इलेक्ट्रॉन है, और ये 7 इलेक्ट्रॉन क्या है, ज्यादा है या कम है? ये ज्यादा है, ये ज्यादा है. नंबर्स के 7 तो बड़ी हो गई, तो 8 इलेक्ट्रॉन इसको कंप्लीट करने हैं, ऑक्टेट बनाना है. तो ये क्या करेगा कि 7 इसके पास ऑलरेडी है, और ये एक गेन कर लेगा, इसको एक मिल जाएगी कहीं से इलेक्ट्रॉन, कोई एटम जो है वो इलेक्ट्रॉन लूज करेगा और ये उसको गेन कर लेगा. इस तरह से गेन्ड इलेक्ट्रॉन विल बिकम इट्स वैलेंसी. तो यहाँ पे भी वैलेंसी आपको 1 दिखेगी जैसे सोडियम में दिखी थी, लेकिन इसमें डिफरेंस क्या होगी? सोडियम में 1 वैलेंसी बनी थी लूजिंग से, एंड यहाँ 1 वैलेंसी बन रही है गेनिंग से. So after giving you primary concept of valency, now in this segment I am starting the types of valency, children, and you will try to focus it more towards the topic. Types of valency are basically of two types. One is your electrovalency and another is your covalency. One by one we will take up both types of valency. What is electrovalency? First try to know this. Electrovalency is that type of valency which is formed either by the gain of electron or loss of electron. So it is found both in the metals and non-metals. First of all we will take up that how it is formed in the metals. Metals, as I have already told you, they have some extra number of electron. They are either from the duplet भी एक स्टेबल कन्फिग्रेशन होती है क्योंकि फर्स्ट शेल की कैपेसिटी 2 की ही है और अगर 2 इलेक्ट्रॉन फर्स्ट शेल में कंप्लीटली फिल्ड है तो ये भी बहुत स्टेबल होता है. तो या तो वो डुप्लेट गेन करे एटम या ऑक्टेट गेन करे, दोनों में ही स्टेबल हो जाता है. तो it will gain by either in the case of metals the stability will be achieved by losing electron and this will be the lost electron, the number of lost electron, जिसको कि आप वैलेंस इलेक्ट्रॉन भी कह रहे हैं, आउटर मोस्ट शेल की इलेक्ट्रॉन है. वो जो लॉस्ट इलेक्ट्रॉन है जो कि लूज हो जा रही है मेटल से, दैट लॉस्ट इलेक्ट्रॉन इज मेकिंग इट्स इलेक्ट्रोवैलेंसी. इट इज ऑलवेज फिक्स्ड. इलेक्ट्रोवैलेंसी इज फिक्स्ड. Like in all the metals you will find that the electrovalency are formed by the losing electron. Here I have given you some example. Metals readily lose their valence electron because these valence electrons are more than their duplet or octet, which is the stability hindrance, जिसकी वजह से stability में problem आ रही है. hindering electron भी इसको कहते हैं. तो this outermost electron or valence electron will be lost by the metal and reactive metal will lose it very fast, very readily. Like I have given you the example of lithium which has 3 atomic number, 2 in the first shell and 1 in the next shell. This one electron is lost and that forms the valency. So it is your monovalent. एक इलेक्ट्रॉन लूज हुई, वही एक वैलेंसी है. यहाँ पर मैंने आपको एल्यूमिनियम का केस दिखाया है. एल्यूमिनियम की 13 होती है, 13 यानी कि 283 एंड दीज 3 इलेक्ट्रॉन्स आर द वैलेंस इलेक्ट्रॉन्स एंड दे आर लॉस्ट. So valency will be 3 and aluminium is always and always trivalent. So these are the electrovalency, children. Here some more example of electrovalency in the case of metals. Try to see. This is your nothing but magnesium which has 12 atomic number. So magnesium की 12 इलेक्ट्रॉन किस तरह से अरेंज है? 2, 8 and 2. These 2 electrons are lost because before that energy level which is your M, L is here and in L 8 electrons are present. So why not it will keep this 8 electron by losing the extra 2 electron which disturbs its stability. So here the valency will be 2. Magnesium is divalent. Here also calcium has the electronic configuration 2882. So it will keep 288 and the last 2 electrons it will lose and it will become also divalent. So इस तरह से वैलेंसी मेटल के केस में समझना बहुत मुश्किल नहीं, क्योंकि मेटल में जो वैलेंस इलेक्ट्रॉन है वही जनरली वैलेंसी होते हैं. जनरली मैं कह रही हूँ, नॉट ऑलवेज. There are exceptions everywhere, but I am telling you in general because you have just started studying about the valency. Is a very big topic where lots of exceptions are there. Now try to know about the non-metals. How do they form electrovalency? I have told you that the non-metals have more electrons in their outermost shell and they gain either 1, 2 or 3 electrons to become stable and they gain it. They gain it to become octet. Here I have shown the example of nitrogen which has the configuration 2, 5. तो 5 है तो 7 इसकी एटॉमिक नंबर और 5 इसके वैलेंस इलेक्ट्रॉन, तो इसको 3 चाहिए और ज़्यादा 3 चाहिए तो इसकी ऑक्टेट कंप्लीट होगी. 3 इलेक्ट्रॉन गेन करता है और इस तरह से वैलेंसी हो जाती है 3, यानी कि गेन्ड इलेक्ट्रॉन यहाँ पे वैलेंसी है, नॉट द वैलेंस इलेक्ट्रॉन. वन मोर वे टू कैलकुलेट द वैलेंसी ऑफ नॉन मेटल इज सिंपली डिडक्ट और subtract the valence electron from 8. 8 is the octet and just from the 8 subtract what is the number of valence electron. यहाँ पे 5 है तो 8 minus 5 3. या फिर आप ऐसे भी समझ सकते हैं कि 3 इलेक्ट्रॉन इसने गेन किया है, 5 थी तो 8 तक पहुंचने के लिए. this 3 electron will be your its valence. So gained electron in the case of non-metal is electrovalency I am saying, because in non-metals one more type of valence is found that I will tell you. In the case of oxygen, 8 electrons are present in its different shells. The first shell has 2 electrons completely filled, and the second shell is incompletely filled because it has just 6 electrons. It needs 2 gained electron. आपने देखा होगा कि मैंने gained electron को क्रॉस से दिखाया है, और जो इसके ओन इलेक्ट्रॉन है, ओन इलेक्ट्रॉन को मैंने डॉट से दिखाया. तो ओन इलेक्ट्रॉन ऑफ ऑक्सीजन इज व्हाट? दिस 6 electron, and this 2 cross electron is not its own electron but it is foreign electron, means इसको किसी ने दिया है, डोनेट किया है, and it has accepted to complete its octet. So these 2 gained electron are what? It is its valency. So oxygen is always and always divalent. Similarly, here I have shown the case of chlorine. Very high reactivity is found in the oxygen, chlorine, but not in nitrogen. तो क्लोरीन बहुत रिएक्टिव एलिमेंट है, ऑक्सीजन भी बहुत ज़्यादा रिएक्टिव है, नॉन मेटल में बहुत ज़्यादा इसकी रिएक्टिविटी आई है. तो 287 इज द कॉन्फ़िगरेशन, और इसको 7 इलेक्ट्रॉन वैलेंस शेल में ऑलरेडी प्रेजेंट है. इट नीड्स ओनली 1 इलेक्ट्रॉन टू गेन एंड कंप्लीट इट्स ऑक्टेट, एंड इट हैज गेन बाय दिस क्रॉस इलेक्ट्रॉन इज योर फॉरेन इलेक्ट्रॉन, गेन्ड इलेक्ट्रॉन, एंड दैट इज वाई द वैलेंसी विल बी योर 8-7 आइदर यू से, और गेन्ड वैलेंसी is 1. So 1 valency and monovalent. Now was, I hope that you must have understood about the electrovalency, which is formed in the metals by losing and in non-metals by gaining electron. I am coming to the next type of valency, which is your covalency. Now try to understand what is covalency. Co means what here? Cooperate. Cooperate means if I have something less, then you will share your thing with me. And if you have something less which you need, then I will share my things to you. This is a kind of cooperation, and that is also a way to form valency. Covalency यानी कि आपस के cooperation से जो valency form होती है, और valency क्यों form होती है? क्योंकि उसको octet बनाना है. तो this type of valency is only and only found in the non metals. तो आपको समझ में आ गई होगी बात कि नॉन मेटल्स के पास दो ऑप्शंस है वैलेंसी के. एक तो इसके पास इलेक्ट्रोवैलेंसी होगी, व्हेन इलेक्ट्रोवैलेंसी, व्हेन इट विल गेन इलेक्ट्रॉन फ्रॉम एनी मेटल, बिकॉज द लूजिंग ऑफ इलेक्ट्रॉन इज डन ओनली बाय द मेटल, एंड दैट लॉस्ट इलेक्ट्रॉन फ्रॉम द मेटल इज गेन्ड बाय एनी नॉन मेटल. बट it has one more option of covalency, that is shares electron. Sharing of the electron gives rise to the formation of covalency, and such types of compound are called covalent compound. ये होते हैं जिसके की मेल्टिंग पॉइंट, बॉइलिंग पॉइंट बहुत लो होती है, या तो ये गैसियस होंगे या लिक्विड होंगे. अगर सॉलिड है तो ब्रिटल सॉलिड होंगे, कंबस्टिबल होंगे. जबकि इलेक्ट्रोवैलेंट कंपाउंड जो कि इलेक्ट्रोवैलेंसी से बनती है, मेटल और नॉन मेटल की कंपाउंड होती है. और कोवैलेंट कंपाउंड जो होते हैं वो सिर्फ यू विल फाइंड ओनली नॉन मेटल्स हियर. लाइक हियर आई हैव गिवन यू द एग्जांपल ऑफ कोवैलेंट कंपाउंड, ओनली नॉन मेटल, कार्बन एंड हाइड्रोजन इज देयर. वेयर एज इलेक्ट्रोवैलेंट कंपाउंड के तो बहुत सारे एग्जांपल हैं, दैट इज योर NaCl, सोडियम एंड क्लोरीन. सोडियम लूजेस इलेक्ट्रॉन, क्लोरीन गेन्स इलेक्ट्रॉन, एंड बोथ आर फॉर्मिंग इलेक्ट्रोवैलेंसी. Here you will see that the carbon example I have given you to best to explain the covalency. What happens that elements which are having 4 electron in their valence shell, so neither these 4 valence electrons can be lost or gained, because the fourth ionization energy has not been discovered, because it will lead to the heavy imbalance of charge. 6 इलेक्ट्रॉन में सपोज कीजिए कि 4 अगर निकल जाएगा, कार्बन का इलेक्ट्रॉन लूज हो जाता है, तो इसके पास तो प्रोटॉन तो 6 है ही, और इलेक्ट्रॉन बच गए सिर्फ 2. तो 6 प्रोटॉन विल बी सफिशिएंट एनफ टू पुल द 2 इलेक्ट्रॉन नेगेटिव चार्ज, एंड इट विल fall in the nucleus by the electrostatic attraction, so that the whole model of the atom will what? Collapse. So this is the reason, because the heavy imbalance of charge will occur if the 4 electrons are lost. अगर मान लीजिए कि 4 इसने गेन कर लिया ऑक्टेट बनाने के लिए, तो क्या होगी? 6 protons are fixed and there will be 10 electrons now, and then 10 electrons will pull the 6 protons from outside the nucleus, वो चला जाएगा proton, and then also it will collapse. So in such cases only the covalency is applied, where the sharing will be done, neither gain or loss. I have given you the example of carbon. How does it form the compound? By sharing. Like one compound of carbon is your methane, very common combustible gas, methane, hydrocarbon. तो कार्बन की जो 4 वैलेंस इलेक्ट्रॉन, उसको मैंने अरेंज कर दिया है कार्बन के चारों साइड में, और हाइड्रोजन के पास तो आपको पता है ओनली 1 इलेक्ट्रॉन इज देयर, नो अदर इलेक्ट्रॉन. So that one electron and hydrogen needs duplet, because hydrogen के nearest noble gas कौन सी है? That is your helium. So that hydrogen will try to attain the stability by gaining duplet, and it will need 2 electron, whereas the carbon will need 4 more electron to complete its octet, क्योंकि इसके पास वैलेंस शेल में 4 है तो 4 और चाहिए, तो ये शेयर कर लेगा ना। तो ये इलेक्ट्रॉन हाइड्रोजन की है ना ही ये कार्बन की है। दिस इलेक्ट्रॉन हैज इक्वल राइट ऑफ कार्बन एंड हाइड्रोजन बोथ। हाइड्रोजन के भी इलेक्ट्रॉन पे कार्बन की राइट है एंड कार्बन के भी इलेक्ट्रॉन पे हाइड्रोजन के। दिस इज द वे द बोथ ऑफ द एलिमेंट्स आर कंप्लीटिंग इट्स डुप्लेट इन द केस ऑफ हाइड्रोजन एंड ऑक्टेट इन द केस ऑफ कार्बन, एंड हाउ द शेयरिंग इज डन ब्यूटिफुली। आई हैव ट्राइड टू शो यू दैट दिस इज योर कोवैलेंट बॉन्ड विच इज फॉर्म्ड बाय द शेयरिंग ऑफ इलेक्ट्रॉन, एंड द कंपाउंड का मीथेन इज योर कोवैलेंट कंपाउंड। ये गैस है मीथेन गैस, and it is highly combustible gas, so it is your covalent compound. In another case I have tried to show you with the carbon dioxide, very common gas, carbon which has 4 valence electron, I have arranged it like this, and oxygen has 6 valence electrons, so it is also arranged like 2 either side and 1 up down. Both side of the carbon there are 2 atoms of oxygen, and these 2 oxygen atom will need 2 more electron to complete its octet, क्योंकि इसके पास 6 वैलेंस है तो इसको 2 और चाहिए, तो ये शेयर करेगा। और कार्बन को भी 4 चाहिए, तो ये दोनों साइड से ऑक्सीजन के 2 इलेक्ट्रॉन की शेयरिंग हो रही है कार्बन के दोनों साइड से, तो डबल बॉन्ड यहाँ फॉर्म कर रहा है, 2 कोवैलेंट बॉन्ड है दोनों साइड में, एंड दिस इज हाउ द शेयरिंग इज डन, एंड द कार्बन एंड ऑक्सीजन बोथ आर गेटिंग सक्सेसफुल इन completing its octet just by sharing, and the compound is a covalent compound because both are non-metals here. In the case of water also, children, you can see that the hydrogen has 1 electron and oxygen has 6 electron, and how 2 sides of the oxygen is 1 hydrogen atom, and they are sharing it. Hydrogen becomes duplet and oxygen becomes octet just by sharing. So this is how the covalent compounds are formed, and they complete their octet by sharing. Now children, I have restricted myself to complete the topic in the shortest possible way, but still it has become little lengthier, and try to view the lecture till end, then only the concept of electrovalency and covalency will become clear to you, and my mission will be also a bit complete, so complete it.